Okay, hello, we are live. Good morning, good afternoon, good evening. Welcome on the Learn Grasshopper Live. Today we are going to talk about really great topic, computational design and generative design. Today I have my guest, Rick. Rick, hello Rick, can you hear me?
Yes, hi Chris.
Hello.
I can
Yes,
hear
I
you.
can. Yeah, I can hear you also loud and clear. This always the question. If you can hear us well, just let us know that if you can hear me and Rick right. So we will start soon. Soon. Just we'll start in 4 minutes. So Rick, where are you based right now?
I'm right now sitting in Amsterdam in our Amsterdam office.
Okay. How big is the office? Because Arup, you're working in Arup, and it's a British company, right? Am I right?
Yes, yeah, that's right. I actually have a slide on that soon, but in Amsterdam we have about 200, 250 people.
Okay.
Yeah,
And Arup is one of the biggest, right, companies in the world designing worldwide.
yeah. In the world, yes. In the Netherlands, we are relatively small to some other companies.
Okay.
Yeah, yeah.
Yeah, soon we will go to your slides when you can show more. Mario, hello, Mario. Hello, Omar, Mohammed, people from the whole the world. As always, nice to see all of you. Question before we'll start, still 3 minutes to go. Have you ever worked with optimization tools like Galapagos, Octopus, Wolsey? Just write in the comment if you ever work of one of this. Which one is your favorite, Rick? Like the
That's
best
a good
one.
question.
I know. It's always like it depends. But
Yeah,
if you will just choose one from these three, which one you will go
I'll use
for?
Galapagos because it's
Hmm.
yeah, the most
Oh
famous
really?
one.
Oh really?
You can use it. You can use it and tweak it for anything. Um, but of course, it has its downsides. Uh, Octopus and Wallisai might have better algorithms for multi-objective
Hmm.
optimization. But yeah, if I have to pick one, it's Galapagos.
Okay, that's interesting. I'm
Yeah.
surprised to be honest.
And you?
No, I'm also Galapagos fan because I never went to that much for that advanced
Okay.
optimization, and for like simple optimization, Galapagos is the best one because it's a native and yeah,
Yeah.
easier to use. And we
Yeah.
can see that also our viewers haven't used this plugin. So yeah, so I'm really looking forward to it. And before we will start, we just talked before going live with Rick that today we experience a really huge catastrophe, building catastrophe in US. Huge bridge, Baltimore in USA was hit by the container ship. It's really old bridge, designed 50 years old, 50 years ago. As you can on this picture, you can see that on the right bottom, you can see that we have the electrical lines that have some barriers around. And still, I don't think so. This kind of small barriers around these electrical columns will protect for this huge ship because I cannot imagine how big forces they are from this kind of big ship. But this kind of maybe if they're going to design new bridge, that maybe some protection should be included. Maybe some like 1 kilometer before, some barriers, some lines
Yeah.
showing. Because from my perspective as a structure engineer, you cannot design bridges for that heat. I don't know what is your opinion about that.
Yeah, that would be too ridiculous because then you would overkill all the sizes probably for once in a. Yeah, I don't know.
Hmm.
There are
Yeah,
other measures to take, like you
yeah,
mentioned.
definitely. You're
Yeah,
dimensioning for wind, for earthquake, for all the traffic loads, and
yeah,
some cases for the small ships, but not like this big one.
yeah,
So it needs some protection. So it was really sad message. Some cars were on the bridge, so they are still finding. So we are crossing fingers that they will, as people that they will survive. Okay, so we will go to our topic. It's 2 p.m. Central European time. So let's start it. We have already 100 people live. If you're watching that on YouTube, Facebook, on LinkedIn, so just give a thumbs up. So it will help us to organize more of these live events. Today's agenda, a little bit about 40 minutes, maybe a little bit longer. Rick has some time reserved for us, but we'll try to keep it 1 hour. Q&A session afterwards, 20 minutes. And of course, recording will be available for everyone who will register. If you got already a link to this webinar through email, so you are already registered, so you are tomorrow going to get recording and the Grasshopper files. If you are watching that on LinkedIn profile, so you have to register here. And as I said, Rick is going to share some optimization work with us that everyone can test it, Grasshopper files. And it will be not Galapagos, it will be the Octopus, right? Engine.
Also Galapagos. I'll show three ways.
Nice. Do you have any comparison as well, or is it?
Yes.
Okay,
yes,
that's great.
Hopefully we have some time, but let's see.
Yeah. Okay. And of course, as always, I'm here to see all your comments and all your questions. So if you have any, just write in the chat. 3 benefits of joining this webinar. First, of understanding what is generative design. Many of you just wrote in the comments that never work with optimization tools. Rick is going to show a really amazing examples. I have seen already presentation, and it's really amazing. And as I said, Grasshopper files will be shared at the end. My name is Krzysztof Wojsław. You can call me Chris. I try to promote Grasshopper and parametric approach in the engineering. So that's why 3 years ago I started my own company, and now I'm just dedicated to promote Grasshopper. I'm also a academic lecturer at the 2 universities, at the Norwegian University and at the master program at Ziggurat. But this webinar is not about me, it's about Rick. Rick is really well known already. I already spied a little bit on you on LinkedIn and your profiles. So Rick is going to be a speaker on the Computational Design Symposium that it will be in Berlin. This symposium were always organized in New York City. So it's a first edition in Europe. And you can find there all the people from the whole world working with the computational design, not just only with the AAC industry, but as far as I know, you can find there people from NASA, from Nike, from Adidas, from all over the world. And Rick is one of the speakers. So if someone is interested, so I really recommend to join this symposium. And Rick was also announced as a runner-up talent of the year 2021 by Dutch VN Constructors organization that represents construction consultant firms. So congratulations on that one. It was 3 years ago. I don't know if you still remember, but I found it on your LinkedIn.
Nice.
Okay, so that was a short introduction. I know that Rick has a lot of content to show, so maybe we can just go straight to your presentation. What do you think, Rick?
Awesome. Yeah, great idea. Thanks, Chris. Thanks also for the promo and a nice introduction. And of course, to invite me to give a short presentation about generative design or computational design and how it's revolutionizing engineering. So I'll start with a quick intro for those who joined in a bit later. My name is Rick Titulaer. I'm a structural engineer by background and a computational designer in the Amsterdam office for Arup. I was born in the south of the Netherlands. I'm currently 31 years old. I've studied in Eindhoven and Stockholm. And in 2016, I started as a structural engineer in the Arup Amsterdam office. Today, I'll tell a little bit about the process, how I got from 2016 to today. I have quite some roles currently for Arup, but I'll explain a little bit more in detail during the presentation. So
So
first,
all your experience. So after graduation, you started in Arup, and you just stayed there.
yes. Actually, next week is my 8th-year anniversary, so
Congratulations.
I'm quite happy with that. So let's continue that streak. But for those who don't know Arup is a global firm of designers, consultants, and experts in various disciplines, and we design various projects around the globe. We have about 18,000 members, and we're founded in 1946 with offices, about almost 100 offices in 34 countries. You might know us from a few iconic projects around the world. We have done or worked on the Water Cube and the Bird's Nest, Sydney Opera House, Sagrada Familia. We're helping to finish that building soon as well. Also, some of our aims, which I think is very important to mention for our company. Sir Ove Arup wrote a key speech in 1970, and this is still relevant today. So what he wrote down back then is still our principle for our company. So we aim for the highest quality of work that is possible. We want to design holistically with various disciplines involved. We are a humane organization, straight and honorable dealings. We aim to be social useful, but also with reasonable prosperity for our membership. And all of this led to an update on the key speech a few years ago, because these 6 aims are very important. But of course, now sustainable development is one of the most important things in the world right now. And that is one aim that we've added to the key speech from Ove Arup in the 1970s. Because our world is changing, and you might hear lots of things in the news. We face lots of challenges like climate change, biodiversity loss, resource depletion. And on the other hand, we also have to design healthy and sustainable and also comfortable built environments. And all of this needs to be done within certain regulations, and all with quite often as well in complex boundary conditions. So we came to the conclusion that we need to design according to this mantra, which says form follows people and planet. And I hope today I'll share a few projects which this is one of the aims during these projects. But how do you do this? One wise man once said, if we do all of our exploring within our own heads, we tend to be limited by what we already know. And this wise man is Tristan Carfrey, an Arup fellow. He said this once to me when I met him, and this was really striking because it's exactly what generative design, parametric design, computational design is about, because you can explore options, find options that you might not have thought of before. And this exploring can be done in many stages of a design project, but the most efficient or effective place where to do this is in a very early stage, because then the design is still flexible. You can impact the performance of the project. There's not much cost on design changes yet, so there's a huge potential in exploring different options in the early stages of the design. But generative design or computational design or parametric design can also be used in later stages, because you can write scripts or algorithms to automate your processes. So once a design change comes in, or once you've automated a task, you can decrease the cost of that. So it will also help you in being more efficient. And finally, we also see a big shift into AI, a big theme these days. So we are starting to collect all the data on different projects and starting to put that into machine learning algorithms to learn from that and to actually predict in the early stages how your building or built environments might perform. I'll hopefully show some examples on that as well.
But before we are going to more advanced topics, so maybe we'll first start like with the generative design. What is your like own definition of generative design? How do you define that? Because it's like a big topic right now. Like I know that everyone is talking about AI and machine learning, but let's take some steps before. We have the parametric design, which with everything started with the computational design, right?
Yeah. So I think like all three these principles, parametric design, generative design, and computational design, use algorithms or the computer to perform a design task. With parametric design, you define the inputs, a process, and the outputs, and once you change an input, it will automatically change your output. With generative design, my opinion, you can start to explore these inputs and explore the design space of your design task, and relating that to your outputs or to your goals. So you can start to optimize your structure, or you start to minimize wind hindrance, things like that. And computational design is sort of an umbrella of all of these things, where you design stuff with the computer. Can also be digital fabrication. So I have a slide on that as well later on. But
yeah, sure.
This
Let's continue. I think it's like when we start with this all the terms. So I want to just assure that we are on the same page. Okay.
Sure. So then, how do we go into this process? So we, as Arup, we believe in an integral design process where we go on in, or we tackle these design issues holistically, where we discuss client ambitions, define the boundary conditions of a project, and determine the variables. With this, we can determine our logic, where we can script an algorithm to generate alternatives, if it's buildings, if it's structures, whatever you can think of. And all of these alternatives we link to our analysis. So again, that can be a structural analysis, that can be a solar analysis, a sound analysis, wind analysis. It can basically be anything. When you run these analysis, it will result in data. And this data we usually define as KPIs, how good it will score. You can explore and evaluate that. And within that, you can do an optimization. So you can go back and change your inputs and iteratively generate more options. And then also you can save that data and push that to visual interfaces to explore design options collaboratively in interface, and get informed data-driven insights. This is currently we have done this mostly within Grasshopper. So Grasshopper is our main engine, but we've also put Grasshopper in the cloud, so we can run our scripts in the cloud, which helps us to scale and also to store all of the data online. And with this, we can start to explore more options, because in the early stage you need to make thousands of decisions, and then it's interesting to explore the design space. Like Tristram said, find options that you might have not thought of before. You can actually design efficiently and quantifiably better. You can prove that your design is better than, for example, a benchmark design, because you have that data. And in the end, we aim to collaboratively find the best fit compromise, because the optimum we believe it's not always there. It's always a balance between different KPIs. You can never, in some cases there is an optimum, but I'll show you in some project examples what I mean by that, and also in the live demo in Grasshopper later.
Yeah, we know that like term optimum is different from the different perspective, right? From the structure engineer, as we are structure engineer designers. So it's a optimum is a different aspect of our client. The optimum, maybe it will be the cheapest one, or maybe more, or maybe more most sustainable.
Exactly. So that's what we usually face, and I'll now jump to the project examples. So what can we do with generative or computational design? And I'll go from small to big, and I have 4 hopefully really cool projects to show. The first one is actually quite small. It's the Stedelijk Base in Amsterdam. Together with OMA Architecture and Rem Koolhaas, I was asked or tasked to design the structure of this very thin steel cantilevering structure, so very thin steel structure. As I said, together with Rem Koolhaas, was very interesting. In my first year in Arup, I got to work with star architect Rem Koolhaas himself. We provided structural design, but also acoustic design, vibration testing, etc. So I have a video. This is the Stedelijk Museum. In the basement, we designed these exhibition walls. They are very, very slender, so prone to vibration. And you can imagine with very expensive art, we need to check that if that's structurally sufficient. As you can see, all of these have a very unique shape and connected with steel sheets and bolts, so fully demountable. We created a parametric script where you can actually assess all of these 23 different configurations on static criteria, but also dynamic criteria. What if someone would fall into the wall? We could measure the responses. We stiffened the construction, the structure, because it was a bit flexible in the beginning. And in the end, we used optimization, Galapagos in this case, to minimize vibration, to add stiffener plates in between the walls. And this resulted into a very unique exhibition space with limited amounts of vibration. And also, in the end, the exhibition walls were there for 5.5 years. They were recently demounted and recycled, unfortunately. But many people were very enthusiastic about the very slender structure of just 15 millimeters and 4-meter height. And there were art pieces hanging from these walls, which would cost more than $1 million. So that was
so I
quite.
can imagine. So I can imagine it should be good optimization for all the vibrations and so on.
Yes, yes. And also Rem Koolhaas really loved the process because we had sort of a random pattern of these stiffener plates, but also we tried to find and minimize these plates to find an optimum. And he quite liked that interaction between the walls, which actually worked quite a lot to stiffen it up. And it looked really, really cool. We had a lot of different configurations and constructed it. And you can also imagine, because you can actually touch these walls when they were still there, of course. We had to test also different cases. So in one case, we also tested what if an electric wheelchair would bump into the wall? What would be the vibrations? And we had vibration criteria for all of these expensive paintings that paint would not fall off. So that was a really, really cool case as well while we were constructing this.
Yeah. Like always testing that on the site is really amazing, and just compare results.
Exactly.
It's the best what we can do as from the structure designer perspective. My question, the optimization, like Galapagos, it was just on the placement of the stiffness plates, or it was also the dimension of that what was optimized?
No, just we minimized the deflection of the walls for all different typologies, and that actually reduced the vibration as well. And we used one type of plate with a certain thickness, 15 mil, and one size, and that size was applied on all walls, but then on different locations. And we sort of had an algorithmic rule based on the length of the wall. We would apply 2, 3, 4, or 5 of these stiffener plates, and then we position them optimally.
Were you surprised by some of position? Like, have you, when you get the results of the most optimum, like when you look of this placement of this all the stiffness plates, it was like, okay, I will never design like that, but if computers say so I will put the stiffener plates.
No, in
or
some cases,
it was similar that you.
in some cases it was what you would expect, but in some cases, some other configurations that you didn't expect had almost the same result. And RAM, for example, he liked that option more. So we allowed not to choose the best option with vibration and deflection, but also let the architect influence the design decision as well, but still be within the limits. So that was quite interesting. All right. Next project, Chris?
Yeah, let's go.
All right. So the next one is a bit bigger. It's a project I've been working on since COVID started. It's a residential or mixed-use development in Amsterdam. It's called Elements, of about 14,000 square meters with Kooshoek architects. The design, or we delivered multidisciplinary services on this project, which means structural design, building physics, acoustics, sound, etc. And the concept we came up with in the competition was to generate a building that would be shaped by the elements, because it would be positioned in, we call it the Arup triangle, a few projects in Amsterdam which were done by us. Um, and we wanted to have a very comfortable environment, a very healthy and comfortable building itself. So looking at sun hours, daylight, wind, and then actually explore different configurations on different scales, actually. So on the building scale, we wanted to have optimal daylight conditions inside your floor plans, optimal sun hour conditions, because we love the sun in the Netherlands, in the atrium, but also on the neighboring buildings. Then on the neighborhood scale, we wanted to get all the green from the neighboring parks onto our buildings and have a good wind climate on the roof and below on the ground floor. And on the planet scale, we wanted to have a energy neutral building. So we created balconies around the building with PVs integrated on the balconies. And we were able to reduce the embodied carbon by introducing quite a lot of timber in the structure as well. So we did.
So you can say that most optimum solution in Netherlands is the structure where there are most daylight.
Most daylight, a lot of sun, and very sustainable. So that's what we aimed for. So we couldn't build all of this into our script in this stage, because it's quite yeah, it was a competition, so we had to come up with solutions very quickly. So we came up with the most important ones for shaping the tower, which were the sun, and sorry for the Dutch term, so sun and daylight. So basically sun on the facade and on the neighbors, daylight in the atrium or the garden in the center, and on the floor plan. And then we said, okay, what if we let the computer come up with different shapes of the tower? What would be the optimal for these 4 KPIs? So we basically created a script that could generate different forms of the tower. And as you saw initially, it was more like a pyramid, the first sketch from the architect. But in the end, we got more solutions that scored better on these 4 KPIs, where you have more of a cantilevering structure to the middle, and more narrow to the top, which was actually quite interesting. So we ran through thousands of iterations, explored all of these KPIs, and came up with the concept of this cantilevering tower, where the balconies that we introduced would be providing optional PV, where we could store or get energy from. It also helps with the wind climate in and around the tower. We could introduce the green in a more area on the roof. And also, we reduced the carbon footprint by trying to implement timber in the top floors, where we had the double height apartments. So the in between floor would be a timber floor, and we designed the plinth to be timber as well. So quite interesting. This is one of the images when you enter the building and walk into the inner garden. This is on top of the tower.
It looks amazing.
You see
Looks like
the view.
lots of sun there.
Yes, yes, yeah. It's. I hope it's going to be really nice. On the top right, you see the balcony material, which has the same color as the PV panels that will be there. So, or almost the same color. So it's quite nice.
So actually, it's not you cannot see the difference.
You
Actually,
you
it's
see
the
it a little
same.
bit, so it's a bit darker.
Darker, yeah.
Yeah, yeah. But it's gonna look really awesome. So currently, we're in the construction phase. We recently finished the ground floor. So this is from a few months ago. This is from last week. So we're actually going up. And currently, my role, I started in 2020 on this project as a parametric designer and structural engineer. Now my role is a lead structural engineer on the project. So I'm finishing the project hopefully next year.
Interesting. And about the basement on the algorithm, optimization algorithm, I saw that it was some limitation by the project. I saw the curves, like the yellow curves from the basement floor.
Yeah.
It was that some limitation how much sun will go inside some of the, let's say, restaurant there or some atrium.
Yeah, so there's also an inner courtyard where there's a room. We call it huiskamer in Dutch, where people inside the building can go there and gather and
Okay.
play billiard or something. So they also have some nice sun hours while
Yeah.
they play billiard or
So it was
whatever they're
open
gonna do.
area. So it was open area, and your
Yeah,
invitation was to not make a shadows on that. So it also was one of the limitation how the
yeah, not
building will look like.
yeah, not really shadow. It was more like we want to have as much sun as possible. So it's always, yeah,
Okay.
of course, when it's 9 o'clock and there are buildings around, you cannot get the sun in the morning. But yeah, we sort of try to find the most suitable configuration.
We have question from Tomasz. Do you use for it Galapagos algorithm, or do you make own scripts for optimization?
So for this one, we used the Galapagos for initial exploration and also some octopus linked
And
to our own scripts that do the analysis. So
yeah, but
yeah.
the question is more about the optimization. Have you ever tried to create your own optimization tool, or you are
No,
always using that one what was created and you are happy with that?
I'm very happy with what's there because it's very useful and it works on almost all the cases that I've worked on. So yeah,
Cool.
that's it.
We can go to the
Okay.
next really
Yes,
interesting example.
I see. With time, I need to speed up a bit, I guess.
No, no worries, no worries. Take your time.
All right. Okay. So the next one is another bigger scale. So it's about it's Hartnultien in Rotterdam, also in the Netherlands. It's about 60,000 square meters. Mixed use development, so resi, office, mixed plinth, 180 meters. Again, Arup is doing multidisciplinary design. Currently I'm the lead structural engineer on the project, but in the early phases I was the computational designer, and I'll tell a little bit more about that process. Because the client wanted a tower and they didn't know if it was going to be 180, 200, 220, 60,000 square meter, 65,000 square meter. They wanted to explore options, but we were designing a tower on a very complex site because they wanted to have quite a lot of gross floor area in a very dense place in Rotterdam. So we had to come up with some KPIs, key performance indicators that we wanted to design for. So we wanted to measure the gross floor area. We wanted to see how we could have the most optimal sun hour conditions on our facade, but also on some important squares in Rotterdam. So we didn't want to block the sun to the sunny terraces from the Rotterdam people. Also, we were designing very close to a neighboring building, which would pose some daylight challenges. And on the other hand, we wanted to design optimal wind comfort on the roofs, on the lower roofs, but also on the ground floor. If you construct a high tower in the Netherlands, but I think in many places you need to really think about wind comfort. We did some initial structural assessment, implemented that. We wrote a very smart script to predict settlements because we were constructing a tower only 15 to 10 meters away from a metro tunnel. So we really had to explore how it would affect the settlements. So working together with a geotech advisor, we created an algorithm to predict the settlements of the tower. And finally, we also implemented acoustic performance of the tower. All of these analyses, except the wind climate, can be done within seconds or milliseconds. So that can be incorporated into your design process. But doing a wind analysis, for those who know, usually you do a CFD model, computational fluid dynamic
Mm-hmm.
model, where you try to find the wind patterns and where the wind speeds get higher and lower. That can take up to 4 hours for one model. So within Arup, we invested in research where we could actually predict the wind comfort or the wind speeds within milliseconds or seconds. So instead of running 1200 machine learning models in 20 minutes, or instead of running 1200 CFD models in 200 days, we could run 1200 machine learned models in 20 minutes. And
Oh.
this really helped us to explore the design space of this tower. So we did lots of configurations of the top part of the tower, looking how it would affect the settlements, playing with the daylight on the building next to it, rotating, cutting off the tower on the top to see how that would affect the sun squares where people were sitting on the terrace. And in total, in a few weeks, we designed up to 11,000 options and analyzed it to about 20 KPIs. And you might think then, how can I make this presentable to our client? So we made use of our own built parameter space, which looks like Thornton Tomasetti's Design Explorer. I'll
Mm-hmm.
show that later. But parameter space basically is a visualization of your data. Each line in the space is one design option. And with this space, you can actually filter. So you can say, I want to minimize my settlements, I want to maximize my sun, I want to maximize my daylight, and which options fall within that criteria. And it's a really interesting way of designing because you can actually uh, explore different configurations on most important KPIs. So here you see the final 3 options. So one option might be really good for sun, daylight, and settlements, but another option might be really good for uh, um, constructability. We also put in a constructability KPI. Uh, let's go back one more time. Distance to other buildings, energy potential. So how much energy can we put PV panels on the facade? And in this way, we actually came to 3 completely different options that were chosen by the client and the architect. So we actually provided this space to them, and together we chose 3 options.
Mm-hmm.
And these 3 options were then presented in our Inform platform, which is a visual interface of our design solutions, where we can explore KPIs on the right hand side and explore different inputs on the left hand side. And this then helps the client to interact with the model, to go around, see how the shape of the tower
Mm-hmm.
will look like. And in the end, after the pre-concept design, after these 3 options, we created one option W, and that was the option that we're designing currently. So this is the view from the tower, and this is on the right hand side. You see the current design that we're progressing as we speak.
And the software that you provided to client, have you created this own graphs, like making all this optimization, like just showing graphs and solution? Is it your design in Arup?
Yes, it's an Arup platform. We started to create that 4 years ago, and now we gradually build it up so the client and our design team can interact with our parametric models. They can explore design solutions, see what if they change one parameter, how would it
Mm-hmm.
affect different KPIs. And usually the feedback is really positive because they can actually see the difference going from a benchmark design to option 1 to option 10, that it actually is better. So
Yeah. And the workflow was like you suggested free solution that, in your opinion, was best for 3 different scenarios, and then in the Inform, you said platform Inform, you just presented the solution that everyone now can discuss and choose the best one. So
exactly. So at
and
that
what
time,
was which one was chosen, just from the curiosity?
So it was a combination of X and Y. So they actually merged X and Y into W. So actually it had some of the benefits from option X and some of the benefits from option Y, but it actually gave a lot of insight about what solutions might be actually not working as well on settlement criteria or construction criteria, and it was very insightful.
We have a question from Mauro. Thank you, Mauro, from question. In this case, are you exploring a set of options rather than being guided by the software itself to it?
Exactly. So we're not saying what is actually the best option or what's the best design, but we're exploring the design space itself. So we're also not saying to the client, this is the option. We say, if you are within these limits, this is a direction you can go. So we're not creating the design for the architect or for the client. We're helping them to make informed decisions, and they actually really love to use these tools as well, because then they create better designs.
Yeah, so it's more like a guidance than just clicking one button and just creating a design for us and just solving all the problem and all the issues. Because as you can see, there's Mauro, there's like lots of complex KPIs. Like you said, 20 KPIs that you need to think about it. That's a lot. Like when you need to compare, and it's not just with one solution that solves all the issues, because like different stakeholders have a different definition of optimum.
Exactly. Yeah.
Which parameter did you use for constructability? That's a good question.
That's a great question. So we had a few options of constructing the tower. A highest loads is currently one of the innovations in the Netherlands, where they actually build sort of a a, a, a box around the tower, and that goes up gradually. And that has distance limitations of getting things inside that box, but also distance limitations to the road and to the neighboring buildings. So we actually measured all of these criteria and said if it could be done with this method or not. So that was very insightful.
Yeah, really interesting. Mario asked about if you can show Galapagos script, but we will go to this.
We'll do that later. Yeah.
Yeah, let's go to next project. Really
All right.
cool.
Yeah, this is the final one. So in 2019, I was at the coffee machine in our office here in Amsterdam, and my boss came to me and said, "Rick, do you want to go abroad?" And I said, "Yeah, maybe. Sounds interesting. What's it for?"
Depends where.
It depends where.
If
Is
it's
there sun?
warmer.
So that was the first question. Is there sun? And yeah, there was. So he said, "Do you want to work on a stadium?" And I said, "Yeah, definitely." So he said, "Yeah, in Madrid, they need help on a stadium. Actually, 2 stadia, but I'm going to show you one today." And they need help with the design of the facade. So next project is Bernabeu, the Real Madrid stadium, which I worked on for over a year, which is before I started, was like a dream coming true just after 3 or 4 years.
Just one question. Before you started, have you been a Real Madrid fan or not? Or you
No,
became afterwards?
I'm an Ajax fan, and I personally like Barcelona more than Real Madrid. But anyway, that's another discussion. So we got to help on the new Santiago Bernabeu Stadium, which was originally constructed in 1944. But over the years, they did quite some renovations, and now they wanted to have a big renovation in 2019 or 2017, when they came up with the design with a iconic facade, a retractable roof, and a retractable pitch. and we were doing the facade engineering and the lighting design. So just one section of the design of the stadium, which is almost intact of the original one, except the roof and the new facade around it. And they upgraded some of these towers in the corners to actually carry the roof. Two quite innovative innovations, which I'm not going to talk about, but they're very cool, is the retractable roof. There are many videos on YouTube now because it's actually there, and the retractable pitch. So without going into detail, maybe Chris can send you some links on that later, but it's really awesome. I will talk about the facade design. So here's what they envisioned in 2017-18. So a shiny steel facade, very organic, different complex shapes. Consists of triangular panels, and these triangular panels were quite reflective. And that was one of the challenges. So this was the building when I was there in Spain in 2019. And this is a few months ago when I visited Madrid, when it's almost finished. So I helped with the facade design, a complex geometry of more than 11,000 panels. They designed a system to hang these triangular panels from a secondary supporting structure. But you can imagine with the complex shape that I've showed in the previous renders and videos, it might be very hard to construct it, or very prone to errors, etc. So after some initial exploration of the geometry, like what's the angle between the panels, looking at these nice rainbow coloring images, the most interesting question came. I don't know if you've heard the story about the car that was fried in London.
Yes.
They were very worried about cars and people being fried by the stadium. So we had to explore how the sun would actually reflect on the stadium into the environment, because there were big roads next to the stadium, but also large building blocks that might
So
have issues.
it can be really dangerous, right? Like
It could
not
be
that
really
many.
dangerous. Exactly. So that's why we did a lot of work on the facade design. So first we generated the geometry parametrically. We ran a glare analysis, which is a reflection analysis of the sun. Then we explored configurations of the facade that could be maybe better for reflection. We recreate the geometry, which would be then the final geometry that would be constructed today. Did some validation with more detailed glare analysis software, and exported our final design into Unity for presentation to the client. So what is glare? It's basically the reflection of the sun on the facade to the neighbor, to the outside. And so we actually did analyze all these panels from the original geometry, and we could see that there were quite some worrying cases of the buildings around and the roads. So we decided to change the geometry to find better solutions for the facade. And how we changed the geometry was basically shifting or tilting the panels slightly or big to see how that would affect the reflections on the neighborhood.
And
So
the
here you
whole
see,
facade, the shape, the whole stadium was the same. You just
yeah,
tilted the facade, like the angles, right?
yeah. So the original shape we got from the architect, and we decided to explore new configurations. So here you see one example panel. So if you rotate it more and rotate it more, you go from 8 hits for this specific point to 3 hits, but then the facade geometry is completely changed. So it was also in a discussion with the architect, to what extent can we change the geometry, and to what extent are we improving the glare. So we built some algorithms to analyze that, because you can imagine for more than 11,000 panels and analyzing different sun positions, it takes a lot of time. So we built our own script that could actually calculate the reflection. And here you see the angle rotation of the the panel versus the number of hits to the environment. So you can see if we rotate it a lot, it's more blue. If we do nothing, it's quite red, especially on the south facade. So where then are we positioning our design? Do we want to deviate a lot from the original? That means that we're tilting it a lot and we have a very low amount of hits, but then the architect or client might not like the design. Or are we accepting some hits and changing maybe the material reflectiveness of the steel in that case? So we had to play with that. But with our model, we could actually explore different configurations. So this is, for example, an illustration of the rotation that is needed to have the least number of hits. So you need to change your geometry a lot. But if you accept a little more, you change it a little less. If you accept it even more, then you only have to change a few of these panels. So in the end, we were somewhere in the middle. So we still had to change the reflectiveness of the steel as well. But we created an algorithm to actually use the results of the glare and still have a fluent facade design. So with Gaussian functions and rounding and blurring numbers, we were able to recreate the facade shape to have better results for glare. And this resulted in a change of geometry, which we then presented to the client in Unity, where they could explore the different geometry configurations and see with the detailed design how it would affect on the different locations. So that was quite received well. And then here again an image from the back side of the stadium when I went in January with my colleagues inside of the stadium. Nice. And some nice acceptable reflectance of the facade.
Yeah, that was actually what I was about to ask. Have you seen the glaze on the structure?
Yes, yeah. I mean, I think it looks spectacular. I went for a few days to visit our office there. The first day it was raining, so it looked completely still and normal. But the next day it was sunny and it gives a very interesting feeling. It was not bothering, but maybe I'm biased.
You could predict where the glaze will be, right? So
you
could see the picture and the comparison, the real picture, and from the optimization model, and find that. So you're saying that I was interested about the one slide that you showed. On the right side, we have a graph. It was the Gaussian distribution.
Yeah.
Okay, so that was when this was the algorithm to find this sweet spot, right? Where is the most optimum?
No, so the Gaussian function was used to smoothen the results of the glare study. So sometimes we had one panel which was scoring bad, and the next panel was scoring quite good. So the difference between them would cause a very abrupt change in geometry. So therefore, we smoothened the glare results with the Gaussian function to recreate the geometry with the Gaussian function, because that's a fluent shape. So that was quite interesting.
It's not just interesting from my perspective. We have nicely done and extremely interesting. Grande Benny.
Awesome.
Actually, we can answer all. We are answering all the question in the meantime. So we can maybe go to this one. Question from Francisca. How did you avoid running the simulation to minimize computational times for every KPI in the building alternatives? Was there a considerable loss in accuracy in the results?
How did you avoid running the simulation? So we basically didn't want to minimize computation time. I think this is referring maybe to. Is this referring to this project or the previous project?
I think the previous one.
So we actually calculated all the options that were in inside our design space, and that was within an acceptable time. So we're not trying to let out some results. So we're not really minimizing computation time at that project. But that's of course a very interesting point, because usually the design space is very big. And then you need to accept maybe to only explore a few inputs, or you need to increase your range of your exploration, and then your results might get more inaccurate. So that's a play you need to define, and it's different for each project.
Cool. We still have 10 minutes, so maybe we can go
Alright.
to the scripts that you presented.
Yes, I will skip the now what. I had a few more slides. Form follows function. Start by doing. So that's
I like
my
this. I like this approach. This is my
yeah.
motto of learngrasshopper.com.
Exactly. So this is the most important one. You can do trainings and etc. But the best thing is to find an actual case and just start exploring Grasshopper, try different plugins, different solutions. So on this slide, I have summarized a few of the plugins that we use on this workflow. Yeah, the main ones for optimization are like Chris showed before: Galapagos, Octopus, Wallasai. And for the visualization, there are some really interesting tools. Human UI is a very nice one, and Design Explorer, which I wanted to show today. But we have not much time, so I'll go to the live demo. And the live demo is about a valley. So the valley where you have some houses in Austria, and they are gonna construct a tower on a location in the valley. And then they ask, like, what's the most optimal location for all houses to have a TV reception, but not construct a 500-meter tower.
Okay.
So that was the goal. So how could you then go into that? There are three approaches, and Chris will share the script afterwards. So the first approach is brute force, like the Hartnell Teen Tower. We just brute forced all the possibilities. We said, okay, let's calculate all options within a certain range, and we just analyze them using the tool Colibri. So if I fly now, you see it will automatically calculate all the results. I already did this before. I store the results. It automatically creates a CSV file with images in sort of a structure in your desk. Then you go to Design Explorer, which is a free tool, which looks like parameter space. Then you say get data. You paste your Google Drive or whatever where you've stored your results. And then here you can explore your design. So I want to say I want to minimize my houses without TV. But I also want to have a low tower. You see, I only analyzed 50 meters or 100 meters. So if I want 50 meters, there are a few options that I can choose from. This is one location. So this is one approach. The second approach is optimization. So I'll go to Galapagos and I say, okay, I define my location of my tower and the height of the tower. I want to minimize the height. And I want to minimize the houses without TV. I have built that in the script. So let's now say I want to minimize this with Galapagos, and now simply adding up these two numbers because Galapagos only takes one KPI or objective. And Galapagos is actually then trying to find a solution within that space every time. And it wants to, for each iteration, it will save a few of the best options and use that in the new configuration. It's the evolutionary algorithm. And you can see it goes to this spot, quite interestingly. So it will find a solution where you would have 56 houses without TV and the height of 31 meters. That's interesting. But you can imagine if I increase the height of the tower, again, quite a bit, more people will get reception. So the other number will drop, as you can see. So 4 and 301. So where is the best option, you might wonder, because you might have only budget for 50-meter tower, but you also want, as mayor of this town, you want everyone to have a TV reception. So then you can go also to Octopus, which is the other solver, which can actually do multi-objective. So
what
again,
kind of parameters you have? Coordinates x and y, and the
X and
height
Y
of
and
the
the height. So if I now again try to put in the houses without TV and the height of the tower, but now with Octopus, it looks a bit different. I'll reset and I'll start. So it will also analyze quite similarly to Galapagos, but with a different algorithm. But with Octopus, you can actually see the solutions on a Pareto front. So you can actually see for each iteration, I'm now in the 3rd generation, 4th generation. You are going to see a very interesting line appearing. Whoop. Which is this line here. You see my mouse, right? Yeah. And this is the Pareto front, because on the y-axis, let's see, I'll stop
So on
the
the
analysis.
on the one axis we have the height of the
Exactly.
of
On
the
this
tower.
axis, you have the height. So the higher the tower, you see on this axis the houses without TV. So there is an option. I can reinstate that solution. There's a height of 200 meters and 5 people without TV. On the other hand, you also have a height of 0 meters and 129 meters.
So you don't
Sorry,
have to build any tower.
exactly. Or you can bring this design space to the table, to the mayor, and say, okay, what if we take this solution? It's quite close to both minima. So you have only a height of 55 meters and 23 houses without TV.
Looks like the sweet spot. Like, I like this point where it's placed. It's really like placed nicely here.
Okay, so I'll mark that solution, and if I close my script now, I can bring this to the client table, and it will remember that this one was one of my favorites, or your favorites. So with this, yeah, I'm gonna end the live demo because of time. I'll share the script, or Chris shares the script.
So yeah. For everyone who would like to go through the script, like, this is our approach, learn by doing. So for everyone who will register on learngrasshopper.com/generative design, will get the script. I'm really looking forward to test it myself as well.
Awesome. All right. Yeah. To end of my presentation,
you can just make it big on the big screen.
Okay.
Yeah.
To end my presentation, just one shout out to an event coming up in October in the Netherlands, a hackathon for the Steel Construction Day. We or the steel, the Bouwen met Staal company, or the initiative is being done already for a few years. This year we have Chris as a guest speaker and jury and mentor, walking around during the hackathon, giving people tips on the structural design. So it's about structural, digital, parametric design of some sort of challenge that we'll come up with. So
thanks for the invitation. I already set up this in the calendar, and I'm looking forward to this one. And can we say that people can join still, like, reserve a spot, or?
We will announce this in a few months.
Okay.
But you can mark the date.
Yeah, save the day. Yeah, I'm really looking forward to this one in October. Who can attend that one?
Yeah, so anyone who wants to attend, they can sign up. We'll make more information available in a few months. If you follow me or Chris on LinkedIn, you probably get an update on that by then.
Sure. We have really nice comments. Structure engineering with Grasshopper is so sexy. I really agree when you show this all the all the scripts. A great webinar. We have just two questions. So let's, before going to question, Rick, do you have still 5 minutes to answer all the questions?
Yeah, I have 5 minutes. Yeah, sure.
Sure. So let's think the next webinar on the Learn Grasshopper live, it will be about automating drawings. So we're going to have step back, not going into generative design and advanced computational, but still it's a computational design, but we are going to automate drawing. Unfortunately, we have to still deliver drawings, and I think that for Bernabeu Stadium, they have to deliver drawings as well. And together with Greg, we are going to talk about how we can automate all this process. Okay, so let's go to some questions. Let me see. Oh, lots of thanks for great presentation, super satisfying. Let me see from Mauro. Question, assuming same KPIs, what is changing between generative design approach, wall essay, and design explorer when you are testing all the possible combinations? Is Gen design skipping some solutions?
So when you brute force something, you are limited to your computation power or time. So you're actually limiting your design space to, let's say, maximum 5,000 options, which is something that we use in Arup. When you use an optimization algorithm like Wallasai or Octopus or Galapagos, it actually calculates maybe less options, but it's within the algorithm, it's trying to find the optimal solution of the defined KPIs. So yeah, either one of these options could work. It depends on the project and the time and the computation time as well of your script.
Thanks for the answer. And question from Paolo. For the element project, how did you make the visualization with the multiple solution all on the same plane?
Yeah, we just saved all the geometries in a huge data container, and then just created a grid, and then added a random color. It's yeah,
simple as that. Simple as that.
Simple as that. Try that if you haven't used Grasshopper before. It's a good case.
And the last one, I think this topic is really huge, and we were not talking about the AI so much, but of course, like this is a topic that everyone is talking right now. And I know that you are already starting exploring that topic, right? Where will be this point on switching? Like, what will artificial intelligence with your work that you are doing right now with generative design, that you already have the tools to find the optimal solution? So without any artificial intelligence, just for everyone who is watching that, the generative design is still not the artificial intelligence. Many people can say that it's artificial intelligence, but per definition, generative design is just guiding you to the solution. What kind of impact at your work will have AI?
Yeah, so I think for the analysis types we do and incorporate in our multi-objective search for massing studies, it already helps us with the wind analysis, where we save time from 200 days to 20 minutes, for example. Decision making will be interesting, where you have a exploration of a data set where you not have analyzed all solutions, but with using AI, it might find even better solutions from that data set. So these are things we are exploring, and yeah, my feeling is that within the next few years, at least within 2 years, we have a lot more AI involved in our design process, even though we already started. I guess, yeah.
Yeah, I really like this approach with machine learning to really cut the calculation time that you can predict, make some simulation. And this is where machine learning is coming. And still, before AI, we still have to work. Before, we cannot just go with the AutoCAD drawings and jump into AI. We have to go through the road, and Rick is a great example. We have really good comment. Thanks, Chris, for bringing this talented engineer to the webinar. And I agree. Like, we can see Rick started just from the university and going through like the step-by-step, starting with the parametric design, generative design, everything under umbrella of the computational design. And then you can think about machine learning and then AI. So this is the proper road. Like, you cannot go from the 2D drawings into the AI because it will not work. It will not help you in this particular case. All right, we have really lots of good comments. Thank you, great presentation. Oh, it's super satisfying. Thank you from Olga. Do you have something to add, Eric?
Keep on doing these sessions, Chris. I think it's really good for the community, and I think it helps a lot to see what people are doing, and give them tools and guidelines to start doing themselves as well. So thanks to you as well.
Thank you. I will try to put that, and thank you for accepting my invitation. And see you in Netherlands in October.
Yes, we'll do.
And maybe we can organize the next session when you are going to finish another your project that I already know, but we can still keep it as a secret. But maybe on the next webinar we can just show another project of yours, which I think it's really amazing. Thank you again for those who subscribe on learngrasshopper.com/generative design will get the optimization tool with the 3 different options, so you can start optimizing and working with generative by yourself. Thank you again, and see you next time. Bye bye.
Thanks, Chris. See you.